So at the end of the day, you should have at least one solution that's not in this video, but here's one other possible solution. 20 small tables would seat 120 people, 6 large tables would seat 60 people, so that's another option. So let's continue on. We've got to talk about graphing vertical and horizontal lines, and they're not that bad. We can probably get through this pretty quickly. I want you to come up with some random numbers, so you guys go ahead and jump in there, or if you're watching the video at home, think of some random numbers that will work, and make the numbers not too much bigger than 6 or -6, okay? So make them between 6 and -6. Tyler. Yeah, I believe so. I hope so. Yes. So pick those numbers for me if you could. What numbers do we got? Tyler? Jump on there with a number. Any number between 6 and -6. What?
3.
Thank you. What else you got? Just shout them out.
2.
Thank you.
1.
Good. Give me a negative. Give me a negative.
-5.
Okay, good. So we have all the numbers we need, okay? Ready? We're going to start by plotting this point. What would you say is true about all of these 6 points? All 6 points have a y-intercept of a y value of what? What do all 6 points have a y value of? 4. So take a look here. Y is equal to 4 is the line. This is actually a line in yellow, that highlighted thing. If you look at the y values of all of these, right, they're 4. So what do you think is going to happen if I plot all of these points? If I plot that red point, where am I going to be? I'm going to go 3 over and 4 up. I'm going to be here. Now let's plot the next point, okay? We're going to go 0 over and 4 up. So I'm not going to go left to right. I'm just going to go 4 up, just like that. Let's plot the next point. I've got to go -4 down. I've got to go -4 to the left, sorry, and then 4 up here, like that. Okay, let's plot another point. Let's take this point right here, 1, 4. I'm skipping around a little bit. I'm going to go over 1 and up 4, and I'm going to have a point there. Are you noticing a pattern yet?
Yes.
Okay. If we grabbed one more point, where do you think it would fall? Just give me a description of where it would fall. What do you think? 4. It would fall on the y at 4 right here. So we noticed that. Could we make a line now?
Yes.
Yeah, so here's how you can find horizontal and vertical lines. This is a horizontal line. Horizontal line. That's what that is. So if you are able to do that, could you now try on this same grid? Can you now try to graph the line? I want you to graph the line, I don't know, graph the line y is equal to -3. Okay? So now you try, pause the video, and try y is equal to -3. Graph that line, please. So for clarification purposes, you are graphing the line that's over the now you try, which is y is equal to -3, I believe. And I want you to plot it on that same grid. So I want you to go ahead and try this problem right here and graph it on this grid right there. So try to graph that line where y is -3. So make a bunch of points with a y value of -3. Something comma -3, something comma -3, something comma -3, something comma -3. Then plot them all and see what you get. It's going to look similar to the last one. All right, so hopefully that went okay and you got a horizontal line. And this is going to be one more example that we're going to do. It's the equation of the line x equals -3. So picking some random numbers, I don't know, 4, 8, these are just random. I don't know, 0, I'm going to make that 0, -3, -1, 5, okay? So I just made some random numbers. So I'm going to plot -3 comma 4 because all of these have an x value of -3. Would you agree? I mean, it has x is -3 here, x is -3 here, x is -3 there, x is -3 there, x is -3 there, x is -3 there, right? It's like a firework. Beautiful. They all have a value of -3. If that helps, go ahead and draw those in. So I'm going to go over to -3, and I'm going to go up 4, and I have plotted the blue point. I'm going to go over to -3, and I'm going to go down 3, and I will have plotted this point, the green one. I'm going to go over to -3, and I'm going to go up 5, and I will have plotted the red point. I'm going to go over -3, and I'm going to go up 8, which I don't have space for, so let's just skip that guy. I'm going to go over to -3, I'm going to go down 1, and I'll be here. That's that point in black. And one more point is the purple point. I'm going to go over to -3 on the x, and I'm going to go up and down nothing. I'm not going to go up or down. I'm going to be here. So what do I have? I have a line that looks like this, a vertical line. With a slope, if you remember slopitude, it's an undefined slope. So it's an undefined slope. So that's where we're at with these problems. So hopefully you get a little bit of practice. Go back and watch this video if you're doing this tonight. I really want to talk about this. I don't know that I'm going to have time, but I'm going to start talking about it anyways. We're talking about people working for the railroads, right? And we might wind up doing a couple of these as a Now You Try. We'll finish up this whole unit. But the number of people that work for the railroads in the United States is given by this equation and this graph. So what I wanted to talk about is the important thing is that X is years since 1989, and Y is the employees. Okay, so maybe I should have put Y in a different color. That would have been smarter. Okay, Y is the number of employees. So what I want to do is I want to find the Y-intercept of the line, and I want to know what it represents. So the Y-intercept of the line is where we cross the Y. So I'm on the Y right here, right? I want to know where I crossed the Y-axis, which was right there. Well, I crossed the Y-axis right here, and it's about 225. So it's 225 for the Y, and the X is, of course, 0. So it's the point 0, 225. What does that mean? What year was that? If it's year 0, what year is it? If it's year 0, what year did we start at? What year did we care about? Years since what? 1989. In 1989, what was going on? In 1989, how many people worked? 225,000 people worked at the railroad. Does that make sense? So that's what's happening there. That's the understanding of what that is. It's been 0 years since 1989. It is 1989, and 225,000 people work at the railroad. How many people worked for the railroads in 95? Well, if this is 89, what's number 1? 1990, 91, 92, 93, 94, and 95. How many people are working for the railroads in 95? This is 1995. Looks like it's about, I don't know. Yeah, whatever you want to say. It's a rough estimate, 190,000. I could say 190,000 people work for the railroads. So pause the video and try this last problem, and we'll wrap it up from there. Peace.